Most people, they get excited about this. They want to believe that somewhere out in the cosmos, there's some advanced civilization that's going to come visit us. They see the stars and they think, well, there must be something out there. And in a way, they're right to think that. But here's the thing I want to explore with you today. Maybe they're not coming, and not just because we haven't found them yet, but because they can't come. Or more precisely, maybe the way the universe actually works makes it nearly impossible for them to ever reach us. And I'm going to try to explain why, not by telling you what to think, but by showing you how to think about the problem. Let me start with something simple. I'm a physicist. I'm trained to look at evidence. And when I look at the evidence for extraterrestrial visitors coming to Earth, what do I find? Nothing. Absolutely nothing. Not a single verified piece of evidence. And I think that's important. You have to not fool yourself about this. We say we haven't found aliens yet, but what we should say is, we haven't found any evidence that aliens have ever been here. That's very different. Now, back in 1950, there was a physicist named Enrico Fermi. Brilliant man. And he asked this question at Los Alamos. He said, where is everybody? And it's called the Fermi Paradox, though I think it's more of a puzzle than a paradox. The logic is straightforward. The universe is old, right? Billions of years old. The Milky Way has something like 100 billion stars, maybe more. If even a tiny fraction of those stars have planets, and if even a tiny fraction of those planets have intelligent life, then there should be countless civilizations out there. Some of them should be way more advanced than us. They should have had millions of years to figure out space travel. So why haven't any of them shown up? There are all these explanations people throw around. Maybe they don't want to contact us. Maybe they're visiting, but hiding. Maybe they came a long time ago and left. Maybe we're too primitive. But let me ask you this. If you really think about the problem carefully, if you do the actual calculation instead of just guessing, where does it lead you? What does the evidence really tell us? I think the answer is something much more interesting, and it's much more troubling. The universe doesn't work the way most people imagine it does. Let's talk about one thing first. The sheer impossibility of traveling through space. Now, when I say space travel is hard, I don't mean it's difficult, like climbing a mountain. I mean, it's something close to impossible, given the laws of physics as we understand them. And I'm not being pessimistic. I'm being honest about what the numbers actually say. The closest star to us is Proxima Centauri. It's about 4 light years away. A light year is the distance that light travels. In 1 year, light travels at 186,000 miles per second. You do the math. That's roughly 25 trillion miles. One star, our nearest neighbor in the cosmic neighborhood. Now, at our current rocket speeds, and I mean our current best technology, not the rockets we have, but the ones we could theoretically build, it would take about 75,000 years to get there. 75,000 years. That's longer than recorded human history. That's longer than civilization has existed. And that's to the nearest star. The distances to other star systems are incomprehensibly larger. We're talking about tens of thousands of light years for many of them. The whole galaxy, the Milky Way, is about 100,000 light years across. Even if some advanced civilization could achieve speeds that are 1/10 the speed of light, which is wildly optimistic given the physics, it would still take them 1,000 years to cross the galaxy. And remember, that's assuming they're starting from some other star system and heading toward ours. What's the probability they'd ever aim for Earth specifically? Now, someone always says to me, but what about faster than light travel? What about warp drives? And I have to laugh a little bit. Yes, you can write down equations that suggest faster than light might be possible if you could find exotic matter with negative energy, which we have no evidence of finding anywhere in the universe. You could manipulate space-time. You could create a warp bubble. It sounds wonderful, but when you actually do the calculations, when you're not just being romantic about the idea, but you're doing the math, you find out you'd need an amount of energy equivalent to converting an entire star system into energy. That's not a small problem. That's not an engineering challenge. That's a fundamental limitation of the universe as we know it. I think what most people don't understand, what they really don't understand, is that space is not an ocean you can travel across. Space is a fundamental part of the fabric of reality. When you move through space, you're not moving through something. You're moving through space itself. And space is big, with a capital B. Bigger than our intuition can really grasp. Let me tell you something I've learned from physics. The universe is not designed to make things easy for us. The laws of nature are beautifully simple. but the consequences are often remarkably harsh. So, let's say, for the sake of argument, that some alien civilization has solved these problems. Let's imagine they found a way to overcome the physics that limits us. Maybe they've figured out something we haven't. They've got faster than light travel, or they're willing to spend 1,000,000 years traveling to a new star system. What then? Well, then we have to ask another question. Why would they come here? Why would they come to Earth specifically? Think about the logic. They're somewhere out there in the galaxy. Maybe they detected our radio signals. We've been broadcasting radio waves into space for a few hundred years now. But here's the thing, those radio signals spread out in all directions. They get weaker and weaker the further they go. The furthest we've ever been able to detect Earth's radio broadcasts is a fraction of a light year. A fraction. And as for detecting other civilizations' broadcasts, we haven't found a single one. Not one. So, if other civilizations are trying to find us using the same method we'd use to find them, they're probably not going to know we're here. The universe is old, but the time window in which we've been broadcasting is incredibly small. It's like trying to find a specific person in a stadium by listening for them to speak. But they only speak for 1 second, once every 1,000 years. And there's something else. Even if they did know we were here, even if they detected our signals somehow, they'd have to decide, is it worth the effort? Is it worth the enormous energy expenditure, the risk, the centuries or millennia of travel to reach a planet where some barely civilized primates are just starting to figure out electricity? Be honest with yourself. If you were an advanced civilization, would you? There's a concept in biology and evolutionary theory called the Great Filter. It's an interesting idea, and I think it points us towards something true about the universe. The idea goes like this. If there are so many planets out there, if life should be common, if intelligence should be common, then why don't we see evidence of advanced civilizations everywhere? There must be some kind of filter, some barrier that most potential civilizations run into and don't get past. Now, where could this filter be? It could be in the past. Maybe it's incredibly rare for life to start. Maybe going from no life to simple life is so improbable that it only happened once, or a handful of times, in the entire observable universe. Or maybe it's incredibly rare for simple life to become complex. Maybe the step from bacteria to animals is much harder than we think. Or maybe intelligence itself is the rare thing. But there's another possibility, and this one keeps me up at night. The filter could be in the future. It could be that civilizations do arise. They do develop technology. They do start to build spacecraft and figure out how to leave their planet, and then they destroy themselves, not accidentally, but almost inevitably. You see, technology is a tricky thing. Every single major technological advance is a double-edged sword. Fire keeps you warm and cooks your food, but it also burns down your village. Agriculture lets you feed more people, but it creates hierarchies and warfare. The printing press spreads knowledge, but also allows the spread of propaganda. Nuclear energy could power a civilization, but it can also destroy it in minutes. And now, we're getting into the really dangerous territory. Artificial intelligence, genetic engineering, nanotechnology, all these things with enormous potential and enormous danger. The question is, can any civilization survive the transition from being a primitive species to having the technology to destroy itself many times over? Maybe the answer is no. Maybe every civilization reaches a certain level of technological sophistication and then encounters something, maybe something in their own biology, maybe something in their own psychology, that makes self-destruction almost inevitable. Think about it. We human beings have been around for about 200,000 years. We developed agriculture about 10,000 years ago. We developed science about 400 years ago. And in those 400 years, we've gone from barely being able to fly to having nuclear weapons. The time between discovering that the atom has energy and using that energy to build a bomb that could destroy a city, about 40 years. Think about that pace of change. Is it reasonable to expect that we'll navigate all the dangers that technology creates without destroying ourselves? Is it reasonable to expect that an alien civilization would? Now, I'm not trying to be pessimistic. I'm trying to be realistic. And this is important for thinking about whether aliens will come here. Because if this is true, if the Great Filter is ahead of most civilizations, not behind them, then there might be very few advanced civilizations in the galaxy at any given moment. Maybe there's none right now. We might actually be among the first. Or we might be looking out at the galaxy and seeing the ruins of civilizations that destroyed themselves millions of years ago. This is a strange thought to sit with, isn't it? All these stars, all these potential worlds, but a universe that is somehow mostly silent. A universe that is, in a profound way, empty of the kinds of visitors we imagine. Let me talk about something else. Let's say that not all civilizations destroy themselves. Let's say that the Great Filter is in the past, not the future. That means there could be some civilizations out there that have survived, that have developed technology, that could theoretically reach other stars. Statistically speaking, some of them should be much further advanced than us. Some should have had 1 million more years of technological development. So why hasn't any of them sent even a probe to visit every star system? Why haven't we found any evidence of space probes or robots or any kind of technology from beyond Earth? There's something called the Hart test, named after Michael Hart. In the 1970s, Hart showed that if even one spacefaring civilization decided to colonize the galaxy systematically, using rockets that were 1,000 times slower than the theoretical maximum, they could still completely explore or colonize the entire Milky Way in about 300 million years. That's a long time to you and me, but in cosmic terms, that's nothing. The universe is 13 billion years old. That's 40 times longer than the time it would take to colonize the entire galaxy. So if any advanced civilization wanted to spread throughout the galaxy, they'd have had plenty of time. Yet we see no evidence of it. None. Not a single artifact, not a single probe, not a single sign. What does this tell us? I think it tells us something profound. Maybe, just maybe, space travel is so difficult, the cost so enormous, that even civilizations far more advanced than ours decide it's not worth doing. Or maybe the universe is full of civilizations, and they've all come to the same conclusion. Spreading out through the galaxy is not worth the resources. There's no reward that justifies it. Or maybe there's something even simpler. Maybe there's a moment in every civilization's development where they reach a decision point. They develop the technology to leave their planet, and at that same moment, or shortly thereafter, they have to ask themselves, do we want to continue? Do we want to keep developing? Do we want to risk the dangers of advanced technology? And maybe many of them, maybe most of them, decide the answer is no. Maybe they decide that the risks are too great, and they pull back. Maybe they choose not to develop further. Maybe they create strict limits on their own technology. That would explain the silence, wouldn't it? It would explain why we don't see evidence of a galaxy-spanning civilization. Because if there's a natural tendency for civilizations to self-limit, or to destroy themselves, or to discover that space travel is pointless, then you'd expect what we actually see. Mostly empty space. Mostly silence. Now I want to come back to the original question. Will aliens come to Earth? And I want to give you my final answer based on what we know about the universe and how it actually works, not how we wish it worked. No, they won't come. And here's why. In a nutshell, the universe is so large and space is so vast that the probability of any civilization being aware of Earth, caring about Earth, and then having the energy and resources to actually reach Earth is so small as to be negligible. And even if all of that were somehow overcome, there's nothing here worth coming for. We're not special. We're not unique. We're one planet among billions, in one galaxy among billions. We're interesting to ourselves, but to an advanced civilization looking out at the galaxy, we're invisible. We're not a destination. We're not a target. We're a cosmic accident. But I want to be careful here. I'm not saying we're completely alone in the universe. I think that's unlikely. I think life probably arises in lots of places, at least simple life. But I think intelligent life is rare. And I think technological civilizations are even rarer. And I think surviving to become a spacefaring civilization is rarer still. And the odds of any such civilization coming here, those odds are vanishingly small. There's another possibility that I haven't talked about much. Maybe there were alien civilizations that did have space travel. Maybe they existed millions of years ago. Maybe they did spread through the galaxy. And maybe they all died out. Maybe they all hit their own great filter. Or maybe they all decided space